Good morning, dear students. In today's class, we shall learn about the gastrointestinal motility. We will learn all the types of motility right from the mouth up to the defecation reflex, that is large intestine. What all the movements of gastrointestinal tract are there, we shall study all of them under one heading. Okay? Yes. Coming to the first and most important, the motility of GI tract, that is the mastication. Mastication begins from mouth, right? This is the first GI motility which begins from mouth, that is the mastication. In mastication, first of all, what do we mean by mastication? It is chewing. That is the first mechanical process by which the large food substance are cut into small pieces or small particles and they are crushed or ground into a soft bolus. That is called as mastication. I repeat, mastication means the food that we consume, the food that we put it into our mouth is broken down from large food substances into smaller particles and is crushed into a grounded substance. This is called as mastication. The particles which are crushed and grounded, we call it as bolus. The food particle now is called as bolus. Now, what is the significance of mastication? What is the importance of mastication? Due to mastication, the larger food particles are broken down into smaller ones. The breakdown of foodstuffs into smaller particles. Then, mixing of saliva with the food substance occurs thoroughly. So, because of mixture of saliva with the food substance, the salivary amylase helps in small amount of digestion of carbohydrate inside the mouth itself. Also, it helps in lubrication and moisturing of dry food substance with the help of saliva. So now the bolus can be easily swallowed through the esophagus. And also the taste of the food is better appreciated by mixing with the saliva and distributing it throughout the mouth. These are the significances of mastication. One is breakdown of larger food substance into smaller particles, mixing with the saliva, lubrication and moisturing of food substance so that it can be easily swallowed. The bolus can be easily swallowed down through the esophagus and appreciation of the taste of the food. Now, coming to muscles of mastication, there are four important muscles which are going to help with mastication. They are masseter muscle, temporalis, pterygoid muscle and maxillary muscle. These are the muscles of mastication. So this is the first step in GI motility. So we have learned about mastication. So once the food is swallowed into the mouth, this food substance now becomes soft bolus. This bolus has to be swallowed through the pharynx into the esophagus, through the oropharynx into the esophagus. So next, motility becomes the process of swallowing, that is deglutition. So what is deglutition or swallowing? It is a reflex phenomenon. It is a reflex response where the afferent impulses is carried through the trigeminal nerve, glossopharyngeal nerve and vagus nerve. Okay, we will see what is this swallowing or deglutition. What are the steps of swallowing? So the food that we have eaten has entered into the mouth. From the mouth, it has to enter through the oropharynx into the esophagus. Right? It has to enter through the oropharynx into the esophagus. We have a small amount of soft tissue here. We call it as epiglottis. This epiglottis is going to prevent the food from entering into the respiratory passage. So it is going to direct the food into the esophagus only by closing the respiratory passage. So we'll see what the steps in deglutition. Deglutition or swallowing begins as a voluntary act. We swallow voluntarily, but later the act becomes involuntary. So this involves three phases: oral phase, pharyngeal phase and esophageal phase. So deglutition involves three phases. One is oral phase, pharyngeal phase and the esophageal phase. So what do we mean by oral phase? Oral phase begins in the mouth. In the mouth, we swallow food voluntarily. We do it by ourselves. So we swallow food voluntarily through the mouth. Later it enters the pharynx, that is the oropharynx. In the oropharynx and from the pharynx through the esophagus, the food substance is swallowed involuntarily. So we'll see what are these. Oral phase. Oral phase is also called as buccal stage of swallowing. It is voluntary in nature. The food bolus, which is formed mastication. Now this bolus is collected by the tongue, and this tongue is going to push the food substance back into the oropharynx. This is how it happens. Now we have a small structure called as epiglottis. This epiglottis is going to close down the nasopharynx so that food does not enter into the nasopharynx. Then food does not enter into the trachea. Next phase is the pharyngeal phase. In pharyngeal phase, what happens? The bolus now enters from the mouth into the oropharynx. In the oropharynx, bolus is going to stretch the oropharynx. Here, there are some of the receptors called as stretch receptors. These stretch receptors are going to push this food bolus down towards the esophagus. So first of all, we have the tongue, which is going to push the bolus back into the oropharynx. Then elevation of soft palate and contraction of upper constrictor muscles of the pharynx, which is going to close the nasopharynx. The soft palate and the upper constrictor muscles of the pharynx is going to close the nasopharynx, so food will not enter into the trachea or the respiratory passage, whereas food is going to enter only into the esophagus. Then the root of tongue is going to block the oral canal. Now larynx pulls up, epiglottis covers the opening, and the vestibular folds are going to adduct and close the airway. This is called deglutition area. During this process, there is momentary cessation of respiration. We call it as deglutition area. Pharyngeal constrictors are going to push the food bolus down into the esophagus. This is going to trigger another process in the esophagus. We call it as peristalsis. So this is about the deglutition process in the pharyngeal phase. So I repeat, what happens in the pharyngeal phase? The food bolus that is being pushed back from the tongue into the oropharynx enters into the oropharynx. The food bolus is prevented from entering into the nasopharynx by two structures, soft palate and upper constrictor muscles of the nasopharynx. And then the food bolus is now going to be pushed down through the oropharynx into the esophagus. Now the next phase of deglutition is esophageal phase. What happens inside the esophagus? In the esophagus, food bolus is going to be pushed down through the esophagus towards the stomach by a process called as peristalsis. Now this movement of gastrointestinal tract, that is peristalsis, occurs right from the esophagus, lower part of oropharynx, from the esophagus throughout the gastrointestinal tract up to rectum and anus. Up to rectum, the peristalsis movement will occur. So wherever peristalsis movement occurs, the process is same. Okay, so peristalsis movement of the GI tract occurs right from the esophagus down up to the rectum. But the intensity of the movement is different in different regions. Now, in the esophagus, what happens to the food bolus? How food bolus is pushed by a process of peristalsis. Peristalsis is produced by a series of localized reflexes. What happens when food bolus enters from mouth into the esophagus? This food bolus is going to push this. Can you see here? It is going to push the smooth muscles in the GI tract, in the esophagus. Now, this stretching of the smooth muscles is going to release two types of mediators. One type of mediator is going to act behind, it is going to constrict the smooth muscle behind and push the food bolus in front. Whereas another type of mediator is going to expand or is going to relax the smooth muscle in front and receive this food bolus which is coming from behind. It is like a wave-like muscular contraction pushes food from behind. At the same time, the part of the smooth muscle which is in front of the food bolus relaxes and it receives the food bolus. If it is a liquid diet, a liquid substance, the peristaltic movement occurs by 1 to 2 seconds. Once in 1 to 2 seconds. If it is a hard food bolus, then the peristaltic movement occurs at a rate of 4 to 8 seconds. That is, one peristaltic movement per 4 to 8 seconds. So this is how peristalsis occurs. We will see in detail about the mechanism of peristalsis in the next slide. Can you see here? This is how peristaltic movement occurs. Food bolus is entered the esophagus. It is stretching the smooth muscles of the walls of the esophagus. This stretch will lead to activation of localized reflexes. What this reflex is doing? It is going to contract the smooth muscles behind the food bolus. At the same time, it is going to relax the smooth muscle in front of the food bolus. So, from behind, it is pushing the food bolus, whereas in front, it is easily receiving the food bolus. So, this is how the peristaltic wave occurs, and it is going to propel the food in front and finally enters into the stomach. So, this is about the deglutition process. So, what are the steps in deglutition process? We have 3 phases of deglutition of swallowing. One is the oral phase, second is the pharyngeal phase, and third is the esophageal phase. In oral phase, the food that has entered through mastication and has formed bolus is now going to be pushed by the tongue into the oropharynx. In the oropharynx, there is bifurcation of trachea, that is the respiratory passage, and the food passage. Food is going to be entering only into the food passage, that is the esophagus. Whereas it is prevented from entering into the nasopharynx and the larynx. Then, from the pharyngeal phase, food bolus enters into the esophagus, what we call as esophageal phase. In the esophageal phase, by the process of peristalsis, food is going to be propelled forward towards the stomach. So these are the steps of deglutition: oral phase, pharyngeal phase, and esophageal phase. So now we have studied about 2 types of gastrointestinal movement. First one was mastication, which occurs at mouth. Second one is deglutition or swallowing. This occurs with three stages: oral phase, pharyngeal phase and esophageal phase. Now let us see what happens to the food which is going to enter the stomach. Food has to enter from the esophagus into the stomach through a small gap. This we call it as lower esophageal sphincter. Sphincter means there is a what do you call it as it's like a gate. Okay, there is a small gate. There is no specialized structure here, but the lower part of esophagus itself is specialized to form a gate-like structure. So this we call it as lower esophageal sphincter. This lower esophageal sphincter is tonically active. It is always constricted. That is called as tonically active. It is constricted. Hence, it prevents the reflux of contents from the stomach back into the esophagus. This process is called as receptive relaxation. This receptive relaxation is mediated by the vagus nerve. So what is this receptive relaxation which occurs either in the esophagus as well as in the lower esophageal sphincter? It is nothing but very similar to the peristaltic movement. There are two mediators: acetylcholine, which is going to cause contraction of the sphincter. Another mediator called as nitric oxide, as well as vasoactive intestinal peptide. I repeat, VIP is vasoactive intestinal peptide. This causes relaxation of the sphincter. If the lower esophageal sphincter does not relax, this is the lower esophageal sphincter. Okay? If this sphincter, when the food bolus enters, it has to relax. If this sphincter does not relax, then the food bolus will start accumulating in the lower part of the esophagus. This condition we call it as achalasia cardia. We call it as achalasia or achalasia cardia. Achalasia means failure to relax lower esophageal sphincter. When does this occur? If there is some problem in the local area. There are some plexus called as myentic plexus. These are localized nerve plexus. If there is deficiency of this localized myentic plexus in the region of lower esophageal sphincter, then this disease will happen. So this is the speciality of lower esophageal sphincter. Now what is the importance of this lower esophageal sphincter? This lower esophageal sphincter is going to contract. Once the food bolus enters, it relaxes. It receives the food bolus enters into the stomach, then it will contract again. It is tonically active, it is always in a contracted state. Only when food bolus enters, it will relax, it will allow it to move it, then again it will contract. Why this is important? Once the food enters into the stomach, it should not go back into the esophagus. We call it as regurgitation. This should not happen. This is prevented by the lower esophageal sphincter. So what is the function of lower esophageal sphincter? It prevents the food from regurgitation back from the stomach into the esophagus. This is the speciality of lower esophageal sphincter. So we have learned two types of GI motility: mastication and then swallowing or deglutition. Then we learned a little bit about the importance of lower esophageal sphincter. Right? Now the food which has entered from the mouth through mastication, entered through the esophagus in the form of peristaltic movement, it has entered through the lower esophageal sphincter. Now the food has entered into the stomach. What happens to this food bolus once it enters into the stomach? We'll see in the next part. Yes, as the food enters propulsive movements or the peristaltic movements. This peristalsis, we have not learned in detail about peristalsis, right? So let us see what is this peristaltic movement. This peristalsis has already started from the esophagus. We will study in detail about peristaltic movement. Peristalsis is a reflex response that is initiated when the gut wall is stretched by the contents of the lumen, that is food contents. So when is peristalsis occurring? Whenever the food that has been entering into the GI tract, whenever it is stretching the gut wall, that is when peristalsis is initiated. So I repeat, definition of peristalsis. Peristalsis is a reflex response that is initiated when the gut wall is stretched by the contents of the lumen. It occurs in all parts of the gastrointestinal tract, right from the esophagus up to the rectum. How often does it occur, or how much movement will occur through peristalsis? The food moves about 2 to 25 centimeters per second. In some parts of GI tract, it will move slowly. In other parts of GI tract, it can move at a rate of 25 centimeters per second. So this is the velocity of movement of food throughout the GI tract by the process of peristalsis. Now, what is the mechanism of this peristaltic movement? Whenever there is a localized stretch, whenever the food which is entered into the GI tract is stretching the GI tract, there is release of the hormone called as serotonin. I repeat, the local stretch is going to release the hormone serotonin. Remember, first hormone in peristalsis, what we are learning is serotonin. This serotonin hormone is now going to activate the myotic plexus. So, food has entered into the GI tract. This food is stretching the structures of the GI tract, the smooth muscle of the GI tract. Because of the stretch, which is the hormone that is released, it is the serotonin. Now, this serotonin hormone is going to act locally. What is going to activate? Myotic plexus. Serotonin activates myotic plexus. Now, this myotic plexus has a speciality. We'll see what it is. It has two types of substances or two types of mediators that can be released. One is the cholinergic neurons. Cholinergic neurons passing in a retrograde direction. You have the lumen like this, right? So there are some neurons which are going backward. These neurons are called as cholinergic neurons. These neurons which are going backward are going to release the mediator called as acetylcholine. I repeat, localized stretch, serotonin activates myotic plexus. Myotic plexus will release two types of mediators. One type of mediator is going to be activated retrograde. Some of the neurons which are present retrograde, they are going to release the mediator in a backward fashion. This mediator is acetylcholine. What does this acetylcholine do? It is going to contract the part of the smooth muscle which is behind the bolus. So, contraction of the GI tract which is present behind the bolus. At the same time, there is release of cholinergic neurons passing in an anterograde direction. It is going to move in the forward direction. So, there are some more myotic plexus which is again cholinergic. These are moving in the anterograde forward direction. These neurons which are going in the forward direction, they will release another type of mediator, that is the nitric oxide in coke. Nitric oxide as well as vasoactive intestinal polypeptide. Vasoactive intestinal peptide Serotonin will act locally. It is going to activate two types of plexus. One is the localized cholinergic plexus, which goes in the retrograde direction, which is going to release acetylcholine, causes contraction of smooth muscle behind the bolus, trying to push the foot bolus in front. Another type of mediator released by the cholinergic neurons, which are going in the anterograde, forward direction. This will release nitric oxide and vasoactive intestinal polypeptide, which causes relaxation of the smooth muscle in front of the foot bolus. Now the foot, there is contraction here, there is contraction here, there is relaxation here, which is going to push the foot bolus in front. This is called as peristaltic movement. Okay. Now this is all about the peristaltic movement. The peristaltic movement is going to push the foot bolus in front. That is the main function of peristaltic movement. Another type of movement which is found in the GI tract is the segmentation and mixing movement. Segmentation and mixing movement. Segmentation and mixing movement begins from the stomach. The retrograde, what happens here? It retards the movement of intestinal contents. It is going to reduce the movement. It is going to reduce the propulsion of the food. But what it is trying to do? It is trying to cause breakdown of the food products and also trying to mix the food products with the localized juices. It could be gastric juice or it could be intestinal juice. It is going to cause mixing of the intestinal contents known as chyme with the digestive juices. Now, so in stomach we can see two types of movements. One is the peristaltic movement, which is going to push the food, that is the bolus which enters into the stomach. Now it combines with the gastric acid. With the help of segmentation and mixing movements, the food is going to mix with the acid as well as gastric juice. And slowly it is going to be propelled into the intestine, to the duodenum with the help of peristaltic movement. So we have seen two types of movements in the stomach. One is peristaltic movement, the second is segmentation or mixing movements. What happens in segmentation or mixing movements? So can you see here? The whole of the GI tract will be forming segments. It's called different segments. So what happens? Once there is contraction here at this part, there are smaller segments formed. This mainly occurs in the intestine, the small intestine. Okay. There is this type of movement is also seen in the stomach. Then, at the next moment, this part is going to relax, whereas this part, the middle of this part is going to contract. So now it becomes like this. The part of the intestine or the stomach which has already been contracted, now it will relax. The other part will contract. So the food which was here will now break down to form two different structures. Like this, it is going to help in breaking down the food products into smaller kind, and then also it helps in mixing of the substance with the juice. The next type of movement is the basic electrical rhythm. This is actually not the movement of GI tract, but this is how it is going to produce the contractions in the whole of GI. This we call as basic electrical rhythm, BER, or basic electrical rhythm. So this basic electrical rhythm is actually going to produce the various types of contractions in the GI tract. What is this BER, basic electrical rhythm? It is the spontaneous rhythmic fluctuations in the membrane potential. This spontaneous rhythmic fluctuations varies from minus 65 millivolts to minus 45 millivolts. This is initiated by a specialized type of cells called as interstitial cells of Kachar. In the stomach and in the small intestinal cells, these are located in the outer circular muscle layer near the myelin plexus. This basic electrical rhythm is produced by interstitial cells of Kachar. These interstitial cells of Kachar are situated in the outer circular muscle layer near the myelin plexus. In the colon, they are present near the submucosal border of the circular muscle layer. So this basic electrical rhythm, which is going to produce spontaneous rhythmic fluctuations, is actually going to produce the various types of motility, GI motility. Now, what is this basic? How this basic electrical rhythm occurs? Do you remember the action potential, depolarization, repolarization? Yes, this is something similar to that. We had learned that in skeletal muscle, this is occurring in the smooth muscles of the GI tract. Can you see here? This is the depolarization part. The depolarizing portion of each spike. This depolarization is due to calcium influx. The ion which is responsible for depolarization in the smooth muscle is calcium ion. And the repolarization is because of potassium efflux. Similar to skeletal muscle, it is the potassium efflux which is due because the repolarization. But depolarization, ion responsible here is calcium influx, inflow of the calcium ions. Whenever there is acetylcholine increase in the acetylcholine release, the number of spikes and the tension of the smooth muscle increases. Whereas epinephrine decreases the number of spikes as well as the tension in the smooth muscles of the GI tract. There is one more type of motility seen throughout the GI tract, and this is called as migrating motor complex. What is this migrating motor complex? To tell it in a simple word, migrating motor complex occurs when the whole of GIT occurs when you have not taken meals. We can say it as in between meals. That is, when you are in between the food intake, when the GI tract is empty, a motility occurs inside the GI tract, what we call it as migrating motor complex. You can also say it as the motility which occurs during the fasting state or in between the meals. It has three phases. Phase 1 is called as quiescent period. Phase 2 is period of irregular electrical as well as mechanical activity. Phase 3 is burst of regular activity. All these phases occurs in order to produce the gastrointestinal motility. Till now, the peristaltic movement as well as in the segmentation contractions, we learned about two types of GI motility. When we came to stomach, isn't it? One is peristaltic movement. Second was segmentation or mixing movements, isn't it? In both the movements, there was food. The stretch caused by the food was initiating the motility. But here, migrating motor complex, there is no food which is going to stretch. So when there is no food intake or in between the meals, still we have gastrointestinal motility occurring spontaneously. This is called as migratory motor complex. Now, why do we need this migratory motor complex? There is no food to get digested. There is no food to get propelled. But still, this is very essential because This is going to clean up the GI tract. Whatever food particles are left out in the GI tract will be propelled and it will clean up the whole of GI tract by the help of migratory motor complex. This has three phases, phase 1, 2 and 3. Okay. So migratory motor complex is initiated by a hormone called as motilin. I repeat, migratory motor complex is initiated by a hormone called as motilin. Then gastric secretion, bile flow and pancreatic secretion increases during each migratory motor complex. The importance of this is they clear the stomach as well as small intestine of the luminal contents and they prepare the GI tract for the next meal. Coming to one of the applied aspect, that is vomiting. When does vomiting occurs? Or what is the mechanism of vomiting? Vomiting is the reversal of flow of the food contents. Right? Normally, how food contents will flow from mouth towards the anus. But in the act of vomiting, food is going to get regurgitated. It is going to move in an opposite direction. The lower esophageal sphincter and the esophagus will relax and it is going to propel the gastric contents out. It is going to eject the gastric contents out. The irritation of the mucosa of the upper GI tract is one of the triggering factors for vomiting. Now the impulses are relayed from the mucosa to the medulla over the visceral afferent pathways in the sympathetic nerves and the vagal. So the impulses are relayed via sympathetic nerves and the vagus. Hirschsprung's disease or aganglion pneumocolon we will study in the next slide. After the large intestine motility, we will study about this disease. Now coming to movements of the small intestine. Motility of small intestine. Small intestine makes up about 3/4 of the length of the whole of GI tract. Okay? It is about 5 meters in length and the food that is going to enter into the duodenum, we call it as chyme. Food bolus, which is entered into the stomach, mixed with the gastric contents, now forms the chyme. Chyme typically takes around 2 to 4 hours to traverse across the small intestine. Now, what are the different types of movements seen in small intestine? One is propulsive movement, that is peristalsis, mixing movements, that is segmentation movements, and then the movements in the villi. Peristaltic movement we have already studied, isn't it? It is the same peristaltic movement which occurs in the small intestine. Same mediators. It is the serotonin going to activate local myelin plexus, release of acetylcholine, contraction of the smooth muscle, propel the food contents, propel the chyme in the forward direction. Nitric oxide and vasoactive intestinal polypeptide relaxes and receives the chyme. Same propulsive or peristaltic movement. Similar mixing or segmentation movements that we have seen in the stomach. There is another type of movement called movements in the villi, which is going to help in absorption of the contents, contents of the chyme. The food contents will be absorbed through the movements in the villi. Small intestinal movements, the motility during the digestive period are these three: propulsive movement, mixing movements, and movements of villi. During interdigestive period, we also see migratory motor complex, which we have studied in the previous slide. Coming to the mixing movement or segmentation contraction. Again, we have already studied this mixing movements. We will quickly recapitulate what is this segmentation contraction. It is the most common type of movement that occurs throughout the digestive period in in a rhythmic fashion. This movement occurs in a rhythmic fashion. A small segment of 2 to 5 centimeters is formed, which is going to contract. Now, this process is carried out by longitudinal muscles, which are going to relax, while circular muscles are going to contract. This is going to alternate the sections and helps in mixing of the food. If you look at the segmentation contraction, see here, the whole of intestine is formed into different segments. Hence, we call it as segmentation contraction. The food which was this big, the thigh which was this big, will be broken down by the contraction of this part. Now, it forms 2 smaller parts. Now, again, this will contract. So, it will break down the food content. So, like this, the thigh will go on getting broken down into smaller particles. This is segmentation contraction. Peristaltic wave, yes, you remember, contraction behind the thigh, distension in front of the thigh, and helps in propulsion of the food. That is the thigh. So, what is the function of this mixing movements, or the what do you call it as segmentation contraction? Function of segmentation contraction or mixing movements is it helps in mixing thigh with the intestinal juice, pancreatic secretion as well as bile secretions. I repeat, the mixing movements or the segmentation contraction helps in mixing the thigh with the intestinal juice, pancreatic juice and bile secretions. It also slows down the movement of the thigh. It is going to delay the movement of the thigh in the small intestine. By delaying the time, by keeping the thigh inside the small intestine for longer time, it is going to increase the contact time with the villi so that the absorption of the nutrients is easier. So, it is going to help in the absorption by delaying the transit time. Now, frequency of this mixing movements is higher in the proximal part of the intestine, that is the duodenum and jejunum, than in the distal part of the small intestine. The distal part helps in propelling thigh towards the foot. The rate of the mixing movements is 12 per minute in the duodenum, 8 per minute in the ileum. So, you find lesser frequency in case, higher frequency in case of duodenum, 12 per minute, whereas lesser frequency of mixing movements or segmentation contraction in ileum, that is 8 per minute. And duration, how much time it will last? One contraction will last for about 5 to 6 seconds. This is about the mixing movements or the segmentation contractions in the small intestine. Propulsive movements, we are studying this in detail. It is also called as peristaltic movement. It is a coordinated pattern of smooth muscle contraction and relaxation, where wave of relaxation precedes the wave of contraction. There is relaxation in front, contraction behind, so bolus is going to be proper. That is spine, bolus as well as spine will be proper. We call it as bolus in esophagus. Chyme is formed inside the stomach as it enters into the small intestine. We call it as chyme. Now, propulsive movement or peristaltic contraction consists of deep circular ring of contraction, which is preceded by a wave of relaxation that passes at a rate of 0.5 to 2 centimeters per second. When you look at the propulsive movements or the peristaltic wave, it looks like a worm. So, it has worm-like appearance. And chyme moves at a rate of 1 centimeter per minute. The neck movement is very slow. It takes around 3 to 5 hours from the pylorus to the whole of through the whole of small intestine. The small intestine ends at ileocecal bag. From stomach, that is end of stomach, pylorus, throughout the small intestine towards the ileocecal bag, it takes around 3 to 5 hours for the whole of chyme to be moved through the small intestine. There is something called as law of gut. What is this law of gut? Law of gut says that the peristaltic wave of GI smooth muscle contraction, gastrointestinal smooth muscle contraction, begins at the oral end and moves to the anal end. This law of gut was given by Dr. William Jacobs. According to Dr. William Jacobs, the law of gut states that peristaltic wave of the gastrointestinal tract begins at the oral end and moves towards the anal end. Coming to the movement of villi. Movement of villi, here the contraction of villi, that is, by the contraction of villi there is shortening and elongation. Again short. This is called as milking of the villi. So by this action, villi is going to cause easy absorption of the nutrients from the chyme. Also, lymph flows freely from the central arteries of the villi into the lymphatic system. This movement of villi is initiated by the hormone called as villikinin. Villikinin, secreted by intestinal mucosal cells. This villikinin is secreted by intestinal mucosal cells. This is about the movement of villi. Now coming to the some of the applied aspects of small intestine. If there is an obstruction at the end of the small intestine, we call it as intestinal obstruction, or anywhere in the small intestine we call it as IBS. IBS means cessation of small intestinal movement. We call it as IBS. What are the causes for this stoppage of movement? It could be mechanical cause or it could be functional cause. Mechanical cause, any tumor, any stricture or any band formed in the small intestine can cause obstruction for the intestinal movement. Or functional, mechanically there is no barrier, but functioning is not happening. Example, intestinal atony or paralysis of the intestine. We call it as paralytic IBS. We call it as paralytic IBS. Now, paralytic IBS, the causes for paralytic IBS are direct inhibition of smooth muscle, trauma and intra-abdominal surgeries. If you remember, after any surgery, they will say nil oral, don't give anything orally until you get back the intestinal movements. Right? So you should not give anything, even water should not be given orally until intestinal movements are reverted back. So during any intra-abdominal surgeries, the intestine will go for paralysis, called as paralytic IBS. And reflex inhibition of smooth muscle. In case of peritonitis, fluid accumulation in the peritoneum, called as peritonitis. Coming to functions of the small intestine. What are the functions of small intestine? There are mechanical functions, digestive functions, absorptive functions, and some more functions we will see what are those. Mechanical functions. The small intestine helps in mixing of the chyme with various digestive juices, and also propulsive movements helps in movement of chyme towards the large intestine. This is the mechanical function. One is it helps in mixing of chyme with the digestive juices so that it helps in digestion. Also, it helps in propulsion of the chyme towards the large intestine to throw it out of the water. Digestive functions. With the secretion of digestive enzymes by the small intestine, it has a digestive function. Of course, the most important structure which helps in absorption of nutrients is small intestine. The huge surface area which is formed by the various the folds of the small intestine. We call it as folds. Small intestine is thrown into many folds. We call it as plica circularis, villi and microvilli. They form many folds. It is going to form folds like this. Because of many folds, the surface area is going to be increased, and hence absorption occurs easily. So absorb nutrients flows through the portal system or through the lymphatic system. Also, it has various hormonal functions. It is going to secrete secretin and cholecystokinin. It has activator function. Enterokinase activates trypsinogen into trypsin. It has protective function. It protects the mucosa, protects the intestinal wall. Hydrolytic function. It helps in hydrolytic processes of the enzymes. So these are some of the functions of the small intestine. Now coming to motility of large intestine. We can quickly recapitulate what all we have studied till now. So in the beginning we learned about mastication in the mouth. Then we learned about stages of deglutition. Oral phase, pharyngeal phase and esophageal phase. When we came to esophageal phase, we learned about peristaltic movement. In the stomach, once the food enters through the lower esophageal sphincter into the stomach, in the stomach we learned about mixing movements or segmentation contraction, and we learned about the peristaltic movements. Right? Then we also learned about what are the electrical activity, basic electrical rhythm which is going to cause all these contractions. Then we learned about migratory motor complex. So three important movements in the stomach: propulsive movement, that is peristaltic movement. We learned about the mixing movements or segmentation contraction and migratory motor complex. Right? Then in small intestine, again we had the same movements: peristaltic movement, mixing movement or segmentation contraction, migratory motor complex. Additionally, we also learned about movements of the villi. So these are the four types of movements which are going to occur in the small intestine. Right? Then we learned about the applied aspects in the small intestine and what are the functions of small intestine. Now we are going on to motility in the large intestine. So large intestine begins from the ileocecal valve. Then we have the ascending part, transverse section of colon, the descending part of the colon, the rectum and the anus. We will see what are the different movements in the large intestine and what is the function of large intestine. Then we will learn about the defecation reflex, how the chyme which is entered into the large intestine will now be thrown out of the rectum and anus in the form of defecation reflex. All this we learn in motility of large intestine. Coming to motility of large intestine. The motility of large intestine, frequency of the basic electrical rhythm is going to decrease than that of small intestine. And throughout the large intestine it is going to decrease. It is about 9 per minute at the the basic electrical rhythm is gradually going to increase throughout the large intestine. In the ileocecal valve it is around 9 per minute, but as it goes toward the sigmoid colon, just before the rectum, the basic electrical rhythm increases to 60 per minute. Whereas, how much was it in the small intestine? It was 12 per minute in the duodenum, 9 per minute in the ileum. Okay? So, basic electrical rhythm is now going to increase as we go towards the rectum. What are the different types of movements in the large intestine? The mixing movements in the large intestine is called as house-style shuttling. I repeat, the mixing movements in the large intestine has a special name, and that is called as hostile contraction or hostile shuttling. H-A-U-S-T-R-A-L. Hostile shuttling. The contraction lasts for about 60 seconds. And the function of hostile shuttling is it is going to cause mixing movement or propulsion of the kind. Both. It is going to cause mixing movements as well as propulsion of the kind. If you see here, this is the terminal ileum. This is the ileocecal valve. This is the cecum, ascending colon, transverse colon, descending colon, sigmoid colon, rectum, and the anus. This forms the rectum followed by anus. Right? These are the parts of the large intestine. Hostile movements or shuttling movements helps in mixing of the chyme, and also it helps in movement of the chyme towards the sigmoid colon. Then we have peristaltic movement, which is similar to what we studied throughout the GI tract. It propels the contents at a rate of 5 cm per hour. It takes 48 hours for the chyme to traverse the colon. Then, what are the mass movements? There is something called as mass movement present in the colon. Mass movement means it occurs only in the colon. It occurs for about 3 to 4 times a day. After meals, it lasts for 3 minutes. I repeat, mass movements occurs only in colon. It occurs 3 to 4 times a day. It occurs after meals, which will last just for about 3 minutes. What happens here? Constrictive wing occurs in response to distended colon or irritated colon, usually in the transverse colon. Then, rapidly 20 or more centimeters of colon distal to this constrictive ring will cause, it will lose their constrictions and it will cause contraction. The whole of this part of the colon, beyond the transverse colon, beyond this constrictive ring, the whole of the colon will contract at a time so that it can propel out the whole of the content. It forms in the large intestine, the chyme is going to be converted into fecal material. So this propelling of fecal material is easy by mass movements. So remember this much, mass movements help in defecation reflex. It is going to propel the contents of colon out so that you can defecate the waste material out of the body. This is called as mass movement. Now, the contraction develops progressively. It becomes more forceful for about 30 seconds. Then it causes relaxation for the next 2 to 3 minutes. After this, another mass movement will happen. Like this, a series of mass movements usually persists for about 10 to 30 minutes. This mass movement is initiated by 2 types of reflexes called as gastrocholic reflex and duodenocolic reflex. Now, what is this gastrocholic reflex? If you have observed carefully, as soon as you eat, you feel like defecating. Yes or no? As soon as you eat full stomach, you get a reflex of going to toilet and defecating. So this is called as gastrocholic reflex. This gastrocholic reflex is very high in case of children. If you have observed small infants and children, as soon as they are feeded by milk or feeded by food, they feel like going for defecation. This is the reflex phenomenon called as gastrocolic reflex. What happens here is it involves an increase in motility of the colon in response to stretch in the stomach. Whenever food enters into the stomach, the stretch caused by the stretch which occurs in the stomach is going to produce a reflex, which is going to produce a mass reflex in the colon. This reflex is responsible for urge to defecate after a meal. There are two phases in gastrocolic reflex: early phase or rapid phase, and then there is a late phase or slow phase. What are the neurotransmitters which is responsible for gastrocolic reflex? There are many. A number of neuropeptides have been proposed as mediators of gastrocolic reflex. This includes serotonin, neurotensin, cholecystokinin, and gastrin. These are different types of neurotransmitters, neuropeptides, which are responsible for gastrocolic reflex. Serotonin, neurotensin, cholecystokinin, and gastrin. Coming to the defecation reflex. So similar to gastrocolic reflex, we have one more reflex called duodenocolic reflex. When food enters, when bile enters from the stomach to the duodenum, again a similar reflex is initiated, which is called as duodenocolic reflex. Coming to the process of defecation. Defecation is a process of excretion of fecal material out of the body. Again, we have intrinsic reflex, which is more stronger than the mild reflexes, but both are responsible for defecation. This defecation reflex is coordinated at the level of spinal cord. So we also call it as spinal cord reflex. The center is present in the spinal cord. Hence, in any injuries to the lower part of spinal cord, there is spontaneous defecation. The person will not know when to defecate, how to defecate. The control will be lost if there is injury to lower part of spinal cord, because the lower part of spinal cord is going to mediate this defecation reflex. Now, what happens in defecation reflex? The fecal matter which enters into the rectum is going to cause stretch of the rectum. This stretching of the rectum will now cause pelvic afferent nerves to be stimulated. So I repeat, fecal material entering into the rectum causes stretch of the rectum, which leads to activation or stimulation of pelvic afferent nerves. This leads to impulses. This stimulates impulses, which is going to reach the sacral center as well as dorsal nucleus of vagus. The impulses are now relayed to the rectum, colon, and internal sphincters. Now there is contraction of rectum and colon, relaxation of the internal sphincter. I repeat, fecal material entering into the rectum causes stretch of the rectum. This stretch of rectum activates pelvic afferent nerves. The pelvic afferent nerves are going to carry impulses which reaches the sacral center and dorsal nucleus of vagus. Now impulses are relayed back into the rectum, colon, and internal sphincter. There is contraction of rectum and colon, relaxation of internal sphincter. Now the fecal matter passes into the anal canal because of contraction of both colon and rectum. The fecal material is pushed into the anal canal. Impulses from anal canal again reach the sacral center. Now there is one more nerve, that is the pudendal nerve. This pudendal nerve is inhibited. Inhibition of pudendal nerve will cause relaxation of external sphincter. Internal sphincter is already relaxed. Now external sphincter relaxation occurs and there is expulsion of One is the nerves, that is the pelvic afferent nerve, sacral center, which is going to innervate internal sphincter. Another nerve, parental nerve. Parental nerve inhibition causes relaxation of external sphincter. This is a voluntary action. Relaxation of external sphincter can be voluntarily inhibited. Sometimes you are sitting inside the class, you feel you are getting